Okay, stay. Good morning. Now it's morning, so let's finish that conversation we had last night. I couldn't do last night. It's getting sleepy. But anyway, so let's move this away. Let me show this graphic here. So what we did was for instance, if we had a perfect observations of this perfect star, right? That vary itself in a very consistent way with a period of 3.25. So we create that like curve, and if we observe with 1,000 times over a period of 100 days, we would have this nice like curve. Right? You can just look and see the period, but in fact, we observe only few days. I don't know if you can see, but I'm plotting now data for the days we observe. I don't know if you can see, and I don't know if I can expand this graphic. No, I don't think I can. Let's see. I don't think I can. But what I can do, I can expand. I can expand these for, let's say, 20 days only. Okay, and then I will overplot the few data points observed. In fact, let me is symbol equal 5. Oops. Is symbol equal 5. Duplicate keyword. Is sim size. There you go. Can you see now? With these big dots there. So those are real observing points. Those over here. Another one up there. Okay. So then we submit this data to the routine I send you. And then the routine found the period here, right? So let's copy this and let's call period is, oops, that number. Okay. So what we want to do now is to fold the light curve, right? So how do we fold? So if we plot we call X here. So I'm gonna call X, define here. X is the days that I observe. I define that. And Y is gonna be my perfect shot at that star. Is right here. Oh, yeah. Okay. Just to make it simple to see X and Y. And then, so if I plot X and Y with a symbol we call, let's say 5, same size is equal 4, so you can see well. Oops. Excel. So that's what we got. So we got some crazy thing. So we can't see the period there, but supposedly it's 3.25 days. So let's fold this. So what we do, we take, use a simple prescription we can do, and I'm showing here. Right there. So what we do, we take these observations in X, right? And then we subtract from the first point. And then divide by the period. So basically what we are doing, we are finding how many scales we have of period. So if you take an observation of 100 days, how many periods do you have within 100 days? So let's say if you have a period of 25 days, right? Just to make it simple. So we would have four perfect foldings to do. But if we have an observation of 25, at start of 25 days, but we had observed not over 100, but 110. So we have an extra 10 that is not a perfect phase. So we are starting the 51, right? But we didn't complete it because we didn't observe 125 days. We didn't know. We observed only 110 days. So what we do, we find here how many phases we have within 100 days, and then we subtract from the corresponding integer. Right? So in other words, let me show this. This is just taking and determining where each observing point is within a phase. When we take x minus x0 and divide by the period, basically, right? So we know where the points should be in a phase. So if we subtract from print. If we subtract from the integer corresponding to that, so for instance, we had in the first phase, we observe at the beginning, which is this number, we observe 1/3 into the phase, almost at the end of the phase here, 0.9. So the fourth observation we did was in the phase 3. No, phase 0, 1, 2, the phase 4, in fact. Right? This is the first phase, 0. So 3 would be the phase 4. We didn't observe anything in phase 1 or phase 2 or phase 3. We went to observe the phase 4. But see, in phase 4, 077 is almost towards the end of the phase 4, right? So when we subtract from the corresponding integer that indicates the beginning of the phase, then we have the position of that data point within the phase. Therefore, if we plot, show this. Oh God, no, where is it? I lost it. Well, let's do here. If we plot x minus x naught, right, divided by the period minus the integer corresponding to the beginning of phase, which is long, parenthesis, x minus x naught divided by period. So I'm pretty much shifting everyone or folding everyone to the first phase and plot that against the number. So let's see what I got. See what I got? Beautiful, beautiful curve. So our perfect star is observations have been folded or phase folded, as we say here. And then if I do the same for the perfect observations with many points, Let me show that. So I do plot many days minus many days 0 divided by the period minus many days minus many days period divided by not y, that would be sine of omega 2 pi omega times the days is many days. Yeah, omega t, right? Many days. I think that would be, but just make sure I'm doing right here. So omega is 2 times double precision pi, 2 pi divided by the period, which is 3.254939, something like that, times the following. Let me see if that happened. And let's me plot this with a color red. There you go. I don't know what these lines across represent, but there you go. Yeah. I don't know that one. So if I plot, but I take yes equal 1, I think. There you go. So I'm not connecting anything. Right? So I fold here the observations of perfect star. So that's the idea. So what I would like you to do is see if you can find period within those 20 days or so that you have block observations, and then fold. You can do the folding outside using your IDL command line, right? You do exactly the prescription that I did here. Okay, so call me if you need any more explanation. Okay, bye.